Hi guys, welcome to Johnny Mathematics. This is the last lesson which will help you cover chapter 2 for Edexel A-level maths pure year 2. As ever, my assistant Nina will sure be able to do this. Okay. So if you could put the heading further modulus problems, that would be great. Don't worry about all this stuff on the right. We'll be using that in a minute for the next bit. So, quick recap. If you watch video 1, you should be very happy with how to sketch y equals 3x take 2 when the modulus is around it all. You should know that when you get to the x-axis, it goes up in a V, and it forms a V. That's what it would look like. It's an A-level sketch, so we've got to be able to put these points on 2 over 3, and of course if that was minus 2, that will be plus 2. So having watched video 1 and done the exercise, you should be pretty happy with that. Okay. So there's 2 things you need to know. You need to know when the modulus is around the whole of it, and then you need to know what happens when the modulus is just around the x. Okay. And perhaps you can think about what you think might happen before we actually do it and I explain it. Well, so it's not going to affect when x is positive, so it's going to go all the way down to here. Okay, but say we choose a point here, minus 2/3. Well, if I put in minus 2/3, what's that going to be, Nina, when it's inside the modulus?
Plus 2/3.
It's going to be plus 2/3. So it's going to give you the same value, y value, as this one here. So it's actually going to go straight up like that. So this is actually easier than this one, okay? Because all it does is it reflects in the y-axis. Okay. I think you need to make a note of that. So this one here reflects in the y-axis, and this one here reflects in the x-axis. Where y is less than 0. So when y is less than 0, that is where it reflects. Or I prefer, you just hit the x axes and it bounces up in a V, to be honest with you. That's what I always say. So I think arm with this, and you'll see a couple more examples of this one here. I think read through them and you should be able to do now exercise 2E. Okay. So here is the next bit. Okay. I'll get rid of all this. So are you keeping up, Nina?
Yeah, pretty sure.
You're pretty sure. Okay.
Yeah.
Right. So can you put the heading combined? I'll write it up here. Put this heading. You can just about see that. Put the heading combined transformations. Now, do again, I think pretty sure we did this in year 12. We talked about this, but we certainly did it at GCSE. Okay, and you need to know all these transformations. The thing that really sort of helps me remember these is if we take, say, that is y equals x squared, and I know if we took y equals x squared and we went up 3, that, well, I know that's what it would be like, so I remember it from there. It would go up 3, and that must be down 3. I think the other one that I remember here is, I think we can just about get this on the bottom here, is that, again, if we drew y equals x squared, I know that that is y equals minus x squared, which is just like this one here, isn't it? Which is a reflection in the x-axis. So if I know that this one is a reflection in the x-axis, this one must be the opposite. Anyway, that is how I remember them. I want to go through one tricky example. So fx equals ln x, and x is a real set of numbers. Okay. So do you know what fx equals ln x looks like? Do you think you can sketch that? Well, let's try and do this question. You'll need to know how to do it. So when I'm doing these combined transformations, I always start off by drawing ln x. Okay, so I think I can do that. So you should know that that one there is y equals e to the x. And if that's y equals e to the x, that y equals ln x is the inverse of it, reflection in the x-axis. It's the inverse of it, and that point there must equal 1. So I'm going to try and apply this combined transformation to ln x. Okay. So the first thing I'm going to do is, it says 2fx. So 2fx is going to be, it's this one here, isn't it? So I times the y by 2 in this case. Now, when I look at this picture, I can't see a y anywhere. It doesn't cross a y. There's no coordinate, y coordinate, or it doesn't cross the y-axis. Okay, so it's not going to affect the sketch. Okay, so we've dealt with that. What we need to do now is we're going to have to move the whole thing down 3. And if we move it down 3, it's going to affect where the curve crosses the x-axis. So if I write the equation out, so fx is ln x. To work out where it crosses the x-axis, we're going to make y equal to 0, aren't we? So 0 to ln x. If we let our algebra do its thing, we end up with ln x equals 3 over 2. And we should know that when we get ln x on one side, we can e the other side. It's the inverse. So e to the 3 over 2. So that's it. When y is 0, x is e to the 3 over 2. And you could press your buttons and you're going to get 4.48. And that'll be pretty much it. Okay. Next, So the second one I want to go over is y equals okay. Now we can draw, can't we? Now we can draw ln x. So ln x looks like that there. Okay. And if it is minus x, that's this one here, it reflects in the y-axis. So actually it's got to look like that there, hasn't it? And I'm going to put that point in as it's a reflection. Okay, so we've done that bit in the middle there, haven't we? Then the next part, well, we got a modulus around the whole thing, and we learned earlier on in the video that when it's around the whole thing, whatever is below the line gets reflected like this, doesn't it? I think I can probably, it's easier to do this on the same picture. So that bit there is reflected up, like so. That looks a bit complicated, doesn't it? We reflected it in the y-axis, and then because it's the modulus, when we hit the x-axis, it then reflected. So what was below the line was reflected following that modulus rule. So that is what it would look like. A little bit bizarre, isn't it? But nevertheless, correct. So that's pretty much it, really. Combined transformations, you've got a lot of work to do. If you could now do, you should now be able to access exercise 2F, and I think you can now have a pretty good crack at finishing the rest of the chapter, including the mixed exercise. Thank you, Nina, and thank you for listening and watching.